Select the best reagents to accomplish the following transformation. So in this problem, we are given the starting material and we are given the products and we are asked to come up with the reaction conditions. So we need to look at our starting material, look at our products, and compare two things. Is the functional group changing? And is the carbon skeleton, the number of carbon atoms or how they're bound together, changing? So if we look at our starting material, we have an alkene, a carbon-carbon double bond, and we have a carbon-carbon triple bond, an alkyne. And if we look at the product, we see all carbon-carbon single bonds, so our product is an alkane. We should also count the carbon atoms to see if we have the same chain length. So we have 1, 2, 3, 4, 5, 6 carbon atoms in the starting material. 1, 2, 3, 4, 5, 6 carbon atoms in the product. So we haven't changed the carbon skeleton. What we have changed is the saturation of hydrogen. So we have added hydrogen to this molecule. So it appears that we have taken the alkene and added hydrogen gas to that to get the alkane. And it appears that we have done the same thing with the alkyne, added hydrogen gas to get the alkane. So this looks like normal hydrogenation conditions. So hydrogenation involves hydrogen gas and an active metal catalyst. Commonly used catalysts are palladium on carbon. Sometimes nickel is also used, and sometimes platinum is used. So these reaction conditions are shown in option A. One thing that students often ask about is the equivalence of hydrogen. So this is written as though there's one equivalent of hydrogen, but it's important to note that there is actually an excess of hydrogen gas. And that is due to how this reaction is performed. So because the hydrogen is a gas, when you set up a hydrogenation, what you do is in a sealed flask, you purge all of the air and replace it all with hydrogen gas so that there is always an excess. So this reaction is done under a complete hydrogen atmosphere. And that is why we always have an excess of hydrogen gas. And so it is perfectly reasonable to assume that under these conditions that both the alkene and the alkyne will be completely saturated and reduced to give the alkane.